If there's no existing circuit for your dryer and you have a 3-prong cord, you will need to run a 4-wire circuit and change the cord. This involves several steps to ensure safety and proper operation. Firstly, you must run a new 4-wire circuit. This circuit consists of 3 hot wires and 1 ground wire from the electrical panel to the dryer's location. The correct wire gauge is crucial and depends on the amperage rating of your dryer. Consult the dryer's manual or the nameplate on the appliance to determine its amperage requirements. Once you know the amperage, you can consult the National Electrical Code, or NEC, to determine the appropriate wire gauge for the circuit. Secondly, you need to change the cord on the dryer itself. Start by disconnecting the old 3-prong cord from the dryer. Then connect the new 4-prong cord to the dryer terminals, carefully following the correct color code. The typical color code is as follows: black to hot low, red to hot L2, white to neutral N, and green to ground G. Ensure each wire is securely connected to its corresponding terminal. Thirdly, perform a voltmeter check. Before connecting the dryer to the newly installed circuit, use a voltmeter to verify that the voltage is correct, typically 240 volts, and that there is proper ground continuity in the new circuit. This step is crucial for safety and to ensure the dryer operates correctly. To check the voltage, set your voltmeter to alternating current, or AC volts, and measure between the 2 hot wires. You should read approximately 240 volts. To check the ground continuity, set your voltmeter to ohms or continuity mode and measure between the ground wire and a known good ground, such as a metal water pipe. You should read a low resistance or continuous tone indicating a good ground connection. Fourthly, install the appropriate receptacle. At the end of the new 4-wire circuit, install a matching 4-prong dryer receptacle. The receptacle must be rated for the voltage and amperage of the dryer circuit. Ensure the receptacle is securely mounted and properly connected to the circuit wires, following the color code black to low, red to L2, white to neutral, and green to ground. Fifthly, install a circuit breaker or fuses in the electrical panel to protect the circuit. The size of the circuit breaker or fuses must match the amperage rating of the dryer circuit and the wire gauge used. Consult the NEC for guidance on selecting the appropriate overcurrent protection device. Make sure the circuit breaker or fuses are properly installed in the electrical panel and that the circuit is labeled for easy identification. Finally, complete the dryer installation. Mount the dryer securely in its designated location and connect it to the exhaust vent. Ensure the vent is properly installed and free of obstructions to allow for proper airflow. Once the dryer is installed, test its operation to verify that it is heating and drying clothes correctly. When working with electricity, safety is paramount. Always turn off the power to the circuit at the electrical panel before working on any wiring. Use insulated tools and wear appropriate personal protective equipment, or PPE, such as safety glasses and gloves. If you are not comfortable working with electricity, or if you have any doubts about your ability to perform the installation safely, it is recommended to consult a qualified electrician. Electrical work can be dangerous, and improper installation can lead to electric shock, fire, or damage to property. To elaborate on choosing the correct wire gauge, several factors influence the selection of the appropriate wire gauge for a dryer circuit. Firstly, the ampacity of the wire. The ampacity refers to the maximum amount of current a wire can safely carry without overheating. The NEC provides tables that list the ampacity of different wire gauges based on their material, insulation type, and installation method. You must select a wire gauge with an ampacity that is equal to or greater than the amperage rating of the dryer circuit. Secondly, voltage drop. Voltage drop occurs when the voltage at the end of a circuit is lower than the voltage at the beginning of the circuit due to the resistance of the wires. Excessive voltage drop can cause the dryer to operate inefficiently or even damage its components. The NEC provides guidelines for calculating voltage drop and recommends limiting voltage drop to no more than 3% for branch circuits. To minimize voltage drop, you may need to use a larger wire gauge, especially for longer circuit runs. Thirdly, the type of wire. The type of wire used for a dryer circuit can also affect its ampacity and suitability. Common types of wire used for residential wiring include non-metallic sheet cable or NM cable, and individual conductors installed in conduit. NM cable is typically used for branch circuits and is available in various sizes and configurations. Individual conductors installed in conduit offer greater flexibility and protection, but require more labor to install. The NEC specifies the allowable uses and installation requirements for different types of wire. Also, consider the grounding requirements. Grounding is an essential safety feature that provides a path for fault current to flow back to the electrical panel, tripping the circuit breaker or fuses and preventing electric shock. The NEC requires all dryer circuits to be grounded, and the grounding conductor must be properly sized and connected to the grounding system. The 4-wire circuit provides a dedicated grounding conductor, which is separate from the neutral conductor, providing a safer and more reliable grounding path. Further, consider local electrical codes. Electrical codes vary from jurisdiction to jurisdiction, and it is essential to comply with the local codes when installing a dryer circuit. Local codes may have additional requirements or restrictions that are not covered by the NEC. Check with your local building department or electrical inspector to ensure that your installation meets all applicable codes. To summarize, changing a dryer from a 3-prong to a 4-prong configuration involves several steps. Firstly, running a new 4-wire circuit from the electrical panel to the dryer location. Secondly, disconnecting the old 3-prong cord and connecting a new 4-prong cord to the dryer terminals, following the correct color code. Thirdly, using a voltmeter to check for proper voltage and ground continuity. Fourthly, installing a matching 4-prong dryer receptacle. Fifthly, installing a circuit breaker or fuses in the electrical panel. Finally, securely mounting the dryer and connecting it to the exhaust vent. Remember, electrical work should only be performed by qualified individuals to ensure safety and compliance with electrical codes.